Hello everyone, and welcome to the lecture on map projections and coordinate systems. As you know, in ArcGIS, all data that we use has a coordinate system attached to it, and that's how the data is able to overlay on top of one another, as you see over here in this example. There are two different types of coordinate systems or reference systems that can be used in ArcGIS. One is a spherical coordinate system, and one is a planimetric coordinate system. Spherical are in decimal degrees, while planimetric is typically in feet or meters. Now, before we move on, I want to get into a couple of the little details about where you find your coordinate system information in ArcGIS. So let's go to a map to explore that. As many of you know that you can find out the coordinate system of a particular data layer simply by going to its layer properties and going to the source tab. Here we see that the boundary of Spa State Park is in a U.S. continuous Lambert conformal conic projection, so we're able to understand the coordinate system as well as the units that are associated with it. And you can see that this is actually a projected coordinate system, not a geographic coordinate system, and we'll talk about that in a minute here. Now, if we go to this other data layer that's in this particular view, the Landsat 8 image of Spa State Forest, and if we look at the properties there, one thing you're going to notice two things here. The first thing is that the source tab looks slightly different between vector and raster data. And if you remember, vector data is points, lines, and polygons, and raster data is any data set that's based on pixel or matrix of cells, such as aerial photography, satellite imagery, base maps, that type of thing. Now, if we look here for the coordinate system, if we go down to the spatial reference area, we can see that this is in WGS 1984 UTM zone 18, and the units are meters. So you're able to find the coordinate system for that. Now, maybe and hopefully you're asking yourself the question, wait a second, this is in UTM 84, and the boundary was in a Lambert projection. How the heck are they lining up with one another, because they're not in the same coordinate system? And that's one of the beautiful things that ArcGIS does for us. It reprojects data on the fly. If it knows the coordinate system of both data sets, it can automatically line them up for us, which is a great feature of ArcGIS. But at the same time, we need to be cognizant of that, because when we start doing spatial analysis and measurement, we are going to want our data to all be in the same coordinate system so that our measurements are as accurate as they possibly can be. So that's where you find out the current coordinate system for your data. Now, just to go on to the Windows side of things, just so you can see kind of what this looks like. And many of you are used to looking at the data through Windows, but let's say I go to databases here, and I go to that folder where I just pulled that out of, which is SPA, and the boundary that you see right here, that's this data layer here. And you probably all remember that a shapefile is not just one file, is a collection of files with different extensions, and each of these extensions provides some piece of information for the data. For instance, and you don't see the DBF file extension here, but this is a .dbf, that is the attribute table. The SBN, the SHP, the SHX is the geometry of the data. Is it a point, line, or polygon? And then this PRJ is what's actually defining the coordinate system for the data, and that's the file that's telling it where to place itself on a map. Now, if you remember, when you're looking at data in Windows Explorer versus Catalog, if we go to that same exact location in Catalog and look at boundary, notice that you only see the SHP. all of those other files are hidden behind it. That they're there, but what's nice about managing your data here is that when you copy and paste in here, it takes everything with it. If you copy and paste in Windows, you have to make sure that you're getting all of these, or your data is not going to work. Now, one thing I'm just going to mention, because I know this is something that some of you have asked in the past. When you are actually using a file or a shape file or whatever, and it's in a project, and you look at it in Windows Explorer, you're going to see a lock file, and that just means that it's currently in use in some project that you currently have open. So, like, if you were going to go and zip this together to send it to somebody, you don't need a lock file. Just keep that out of the zip file that you create. So this is where you can tell whether or not it has a coordinate system attached to it. Now, I'm going to go up to this particular example, and I'm actually just going to add this data again so you can see what happens here. So I'm going to go to the Adams County folder, and I'm going to add polling places and voting wards. So now look what happens when I add this to the map. You get this message here that says unknown spatial reference, and it's referring to polling places. So what this is telling us is that it's going to try to put polling places on the map. It's going to do its best to stick it where it needs to go, but it doesn't necessarily know exactly where it's going to go because there's no PRJ file associated with it. So it's going to make its best guess and place it on the map. So when I hit OK, it is added to the map. And that's actually pretty lucky, because a lot of times what would happen is that would end up over here, the polling places and the wards would end up over here, and then they wouldn't be overlaying. So when we look at the coordinate system for this in our source tab, it says that our coordinate system is undefined. And that essentially means that it does not have a PRJ file associated with it. If we look at our voting districts, we can see that this is in NAD 1983 State Plane South, the coordinate system that we're used to working with. And the way that you would find out what coordinate system the polling places is in is by reading the metadata. You can't just assign it the coordinate system you wish it was and that you wish it were in. You have to do some research to track down what coordinate system it was in before you attempt to define the projection. And I just happen to know what it is in the same one as this, but you can't, the one thing that I can't stress enough is that you cannot define a data set's projection based on the coordinate system that you wish it were in. You have to define it in which it was created. So to do that, we can come over here to our catalog. If it starts cooperating with me. And we can go to Data Management Tools, Projections and Transformations, and then Define Projection. We select that which we want to define, which is polling places. We tell it what coordinate system it was created in based on what we read in the metadata, and that's going to be the state plane. And I have that in my favorites just because I use it a lot. But if you had to drill down for that, you would go to Project It, State Plane, NAD 1983 US feet, and then just scroll down to Pennsylvania South. But again, I'm just going to use my favorites. Hit OK. And then click OK again. And you will, the tool will run, and hopefully it will be successful when it runs. And of course it tells me about my license that's going to expire soon. And if you remember from intro and other courses, whenever that little globe is turning down in the bottom right corner, that essentially means that ArcMap is thinking and it's doing something. And when you get the green check mark, it means that it completed the task successfully. If you get the red X, it means that it was not successful. And luckily, I got the green check mark. So now when I go to my polling places data and open up my layer properties, notice it is no longer undefined. It has a coordinate system associated with it. And now if I would go into Windows Explorer and go to where I have that data, you're going to see that there now exists a PRJ file, and you'll even notice exactly when it was created, just a minute ago. So you can tell that that's been an addition to this. So that's how you handle that message that you get of an unknown spatial reference. It just means that you have a little research to do to track down which coordinate system that was in. And if you can't find the metadata, sometimes you can make educated guesses at what it could be, because like that's what I essentially did here. I didn't have the metadata, but kind of figured that's what it was created in. If I would have been incorrect, it would have actually moved the points on the map to based on that coordinate system I assigned. So it's really obvious if you select it incorrectly. If you do select incorrectly, let's say that we selected UTM 18 and it creates that PRJ file, all we have to do is go back into Windows Explorer and delete that PRJ file and run the define projection tool again. So you're not completely hosed if you don't get it right the first time. You can go in, manually delete the PRJ, and rerun the define projection tool. So that's a few little tips about projections in ArcGIS. So I think projections are probably one of the most commonly difficult concepts for students to understand. So I'm going to try to make this as simplistic as possible, and we'll hopefully get in more depth as we go through the various courses and through courses, so you can see what some of the issues are associated with projections. But whenever you go and select a coordinate system, whether you're creating data or just defining a projection like we had, it has so many coordinate systems that you can choose from, and it sometimes can be really overwhelming on what you should select. And you know that there's two categories of coordinate systems. There's geographic coordinate systems and there's projected coordinate systems. And there is a substantial difference between the two. A geographic coordinate system is essentially using the three-dimensional surface to define locations on the Earth. And it uses a datum, which is a start known as another word for a starting point, and it uses a starting point for the coordinate system, and it's based on latitude, longitude is a really common geographic coordinate system, and it's based on the angular unit of measure. So there's no feet, there's no meters, there's nothing like that. Everything is in degrees. A projected coordinate system is essentially taking a three-dimensional surface and defining it on a flat two-dimensional surface. And with that, to take that object that's round and flatten it out, there's mathematical algorithms assigned to it so it's able to do that. Because of that, we are able to assign units to it. So we can have things in feet, meters, and so forth. And you probably have realized that we work mostly in projected coordinate systems in GIS because of the fact that it allows us to do measurements, which is a huge, big deal for most everything in GIS. So to boil it down, those hundreds of projections that you see whenever you go and have to select something, there's many of those you will never touch, because a lot of coordinate systems and projections are based on where you are on the Earth's surface. So we're never going to use an azimuthal projection here in Pennsylvania. So like all of those can be ruled out. There's a whole number that can be ruled out just because they're meant for specific areas of the Earth. In terms of what you are going to commonly see for Pennsylvania data and for US data, in terms of projected, you're going to see UTM, and this is a national coordinate system, and this is used heavily by federal agencies. You're going to see that a lot of their data is in UTM, and UTM is essentially a grid that is placed on the Earth's surface, and each grid square has a number assigned to it, like you saw the 18 north. When I was looking at that other data just a few minutes ago, it will assign a number, and then it will be either a north or a south, and the north and south are indicative of whether or not it's north or south of the equator. So UTM is a very common coordinate system that's used not just in the United States but internationally. And then state plane. Most states they had their own state plane coordinate system that minimizes the distortion for the particular states. And we use Pennsylvania state plane for any of our Pennsylvania maps that we make. So that's one that you are definitely familiar with. In terms of geographic coordinate systems, the ones are probably the most popular. We've all used WGS 1984. Anytime that we're doing anything with like geocoding latitude, longitude, that's the coordinate system that is assigned to it. But you also see the assumed geographic coordinate system. I already talked about this, some projection issues with GIS data. You have the issue of like this unknown spatial reference that comes up on your screen, and a lot of times we tend to ignore these things when they happen, but this is when it's actually a really big deal. This is just telling us that it has an undefined projection, and you should really assign it a projection through that process that I just showed you. Another potential issue is when we were looking at Sproul State Forest, we saw that the boundary was in UTM, and the no, I think it was the image was in UTM, and the boundary was in a Lambert projection. When you're doing things just for data display, that's fine. But if you're doing any types of measurements, you're using the data in tandem with each other, you should actually get everything into the same coordinate system. The way that we would do that is through a tool in our toolbox called Project. And essentially, like let's say, in this case, that our polling places are in state plane and our wards are in UTM, we would pick which coordinate system that we want to use, let's just say state plane, and we would go to this and go to Project and just tell it what data that you want to project and what coordinate system you want it to project to, and it's as simple as that. And as soon as you do that, then, and I'm not going to actually run this tool, but you input the one that you want to project and into the coordinate system, and what will happen, we add it to the map, and it's going to add it exactly at the same location as the other one is, which you're going to think that not going to happen. But then if you look at the source tab, you're going to see that one is in the old coordinate system and the other one's in the new. So again, especially when we get to the advanced class, that's going to be something when we're doing spatial analysis and measurement, you're going to want to get everything into the same coordinate system. Okay, another issue with certain projections, you remember there's geographic projections and there's also projected coordinate systems. Whenever we're working with a geographic coordinate system, it means that we're working with angular units, so degrees. When you're working with data like that, you cannot calculate things like area, perimeter, and so forth. So I think some of you have probably seen a couple of times when you run the calculate geometry tool on a field and it says disabled. That's the reason why it's disabled, is because it's in a geographic coordinate system. Let's see if I have a geographic coordinate system in here. I'm not sure if I do or not. Yeah, let's try it with this one and just see if that will work. So I'm going to go ahead and add a field here. I'm going to call it square miles, because I want to calculate the square miles of each of the states here. And I'm going to put that as double because the square miles is not going to be a whole number. It's going to be something with decimal places, so I'm going to do that. Now if I right click and go to calculate geometry, notice that it says area and perimeter are disabled, and that is because of the fact that it is the units are based on degrees, so you can't calculate those properties. So the workaround for that would be then just to project this into a projected coordinate system so that you're able to do that. And I'm actually going to just delete this field so I don't mess up my data. So just to keep that in mind, if you ever do see that, it just means you're working with a geographic coordinate system. So I already talked about what projection on the fly means. It means that when you have two or more different data layers and they're all on different coordinate systems, ArcGIS is able to line them up for you, regardless of the fact that they're not in the same coordinate system. So I'm going to turn now to georeferencing, and those of you in the remote sensing class have done this already, and some of you are actually very good at georeferencing, especially since there was an exam question last semester on georeferencing. We georeference things that have no geographic context. So things like historical maps, historical aerial photos, where they're just static photos, but they don't line up with all your other data. So the process of georeferencing allows us to get the data into a spatial context. So essentially, this allows us to assign map coordinates to data sets, and common data sets are CAD files, rasters, and so forth. So the process is here. Essentially, what you do is you add the raster data set that you want to align to your projected data in ArcMap. You add control points that link the known raster data set positions to the known positions in map coordinates. And when you need a minimum of four control points. Usually, if you want a good georeference, you're going to need significantly more, but 4 is usually the minimum. And when you're satisfied with your alignment, you can save that georeferencing information so that it adds a projection file to your data set, so that that will carry with it then in perpetuity until you do something to delete it, or which you probably wouldn't, but that would be there. So what we're going to do is just go through some of the georeferencing tools. There's a georeferencing toolbar in your collection of toolbars. You essentially just turn that georeferencing toolbar on, and everything that you have to do to georeference your image will be in that particular toolbar. So what you're going to be doing is using either any data set that resides in the desired coordinate system to add control points. And you're going to see how it gets linked back and forth between the original and the one that you want to georeferencing. A word about control points. As we're doing this, make sure that you spread out your control points. You don't put them all in one tight area, because it's actually going to warp the raster to a point where you're not going to be able to use it. So the more you spread them out, the better luck that you're going to have. And I know that can be sometimes very difficult depending on what image that you're georeferencing. Sometimes the only points that you can find in common on both of the images is in a small area, but try your best to get them spread out quite a bit, because the concentrated ones do yield a very bad registration. After you do establish all your control points and you're happy, you can permanently transform the raster by going to the Rectify command, and that allows you to save the spatial reference of the image, and then it allows you to select what image format that you want to use for your data. I'm a big fan of the IMG format, and also I think a lot of students are like the TIFF option. So those are the two that I would use. When you do rectify them, if you're using the TIFF format, you're going to get a .tfw, and that's going to be we get a PRJ with shapefiles, you get a TFW with a TIFF file, and that's its coordinate system information. So you're going to see additional files being created after you do rectify. So what we're going to do is we are going to georeference a map. So I'm going to go up here to my georeferencing data frame. And I think you all know the pain that base maps can cause in terms of loading. And while I'm waiting for this patiently, there we go. We're here in Midtown Harrisburg. The map that I want to georeference is actually a map that I found online. So let me open up Google Chrome. And I'm going to go to, do a search on the Friends of Midtown, because they have a Midtown map on their website. Okay. And I'm actually going to go to Images. You see this map here? This is just a map that was drawn to represent the Midtown neighborhood. And it's just a JPEG. And I'm going to actually save that image. And I'll put that just right under the L drive. Okay, now that I have that, I'm going to go back to Arc, and I'm going to turn on my georeferencing toolbar. I'm then going to hit my Add Data button and navigate to where I just saved that Midtown map. And notice the message that I get. It says unknown spatial reference. And we just learned what that means. It means that it will put it in ArcGIS somewhere, but it has no idea where to put it. So I hit OK. And you notice it doesn't overlay, so it's just somewhere out in space. So what we're going to do is the process of georeferencing. Now, this could put this, now that we added the map, it could put it in space anywhere. I mean, it could be like way, way off, like this really tiny thing in a white space. So what we want to be able to do is we want to be able to see our base map and the map that we're going to georeference at the same place so that we can work with it a little bit easier. So the first thing that we do in our georeferencing toolbar is tell it what map that we want to georeference, and there's only one, so that makes it easy. And then we go to our georeferencing menu and go to Fit to Display. And what that does, it just moves the map that we want to georeference to the same plane so that we can actually see both of our base map and the map that we want to georeference. Once we're here, there's a couple of things you can do, and this is really all about your preferences and how to georeferencing. I've seen many different ways that people have to georeference, and it's really what makes it easiest for you. It's really really going to be the best method. So right now you can't see the base map. So what some people will do, so you can kind of see both at the same time, they may go and set a transparency to the Midtown map so that you can kind of see through it. So like I might set that to I don't know, maybe a 50% transparency, or maybe a little bit more. This is not the method I normally use. I'm fine with it not being transparent. So you can actually kind of see things a little bit easier of both. The other thing that's, and this is what I do, I just keep it full color, and you can actually turn off the map when you go to find its control points on the other map. So what we do now to get started is we added the control points. And if you hover over that, it actually tells you exactly what to do. And I always do hover over this just to give myself the reminder of which data layer you start with, because that's a big deal, because if you do it backwards, you're going to have some significant issues. So it's telling us to select control points on the ungeoreferenced one first, so the Midtown map, and then we go to the one that is georeferenced. So I'm going to click on this, and I'm going to click on the corner of Front and McClay. So I click there, and you can find that same point here. Because it's transparent, you can see it without a problem. Or if it wasn't transparent, what you can do is just turn off that map and it won't go away, and you can find the accompanying point. I'm going to actually get my zoom first to zoom in, because I want to get it as close as I can. And I'll go click on that again, and I'll put the control point there, and I can turn this back on, and I'm going to actually zoom to this layer. And sorry, it's taking a little long for it to draw. But notice what it did now. Now that I established that first control point, the map actually moved and to warp itself to what I just did with it. So now if I go to the corner of McClay and 7th, and then do the same thing on this map, McClay and 7th, and I go turn this back on, notice what happened. It's automatically moving it as I add each control point. And then I'll go to the other corner. Oop, I gotta refresh. Okay, there we go. I'm gonna zoom in. And find the corner of Forester and Front on this one, and then find the corner of Forester and Front on this one. It moves over, and then finally I'm just going to go to the corner over here, and I'm actually going to get rid of that transparency because I don't like doing it this way. Okay, and then get a control point, corner of 7th and Forester, and again 7th and Forester. Turn that back on, and if I zoom to layer here, you can kind of see that this is now overlaying pretty nicely. And if I were doing this for real, I would actually add a few more control points, but for the sake of this demo, I'm only going to do 4. So let's just imagine that this is the perfect georeferencing. You're completely happy with what happened here. What you can do then is go to Georeferencing, Rectify, And this will allow you to save it as a georeferenced image. This is where we set the output location. So I'll click on this folder to put it in an appropriate location. So L, databases, and let's just stick that in Harrisburg. And I'm going to call it Midtown. You can, again, select whatever format you want and then hit save. Now what we can do, I'm going to actually just turn that one off. You can hit your Add Data button, and if I go to where I saved that, which was Databases, Harrisburg, or maybe it's not finished saving yet. Oh, sorry, just going to the wrong place. And there we have it. We have a georeferenced map. Now, one thing I'm going to say is I picked a very, very easy example right here. This is not typical. For those of you that have used the pen pilot photos, those black and white aerial photography for the state of Pennsylvania, you're going to find that this is really hard when you're using photos like that. Don't think it's as easy as this has shown, because it can be a very time-consuming task. There's a lot of that you can do in order to help in the georeferencing process. What you're doing is you're looking for areas that are at the same location, or landmarks that are at the same location on each image, so that you can assign them together. You can get other data layers, like you can download roads, railroads, parcels, whatever you need to help you georeference appropriately. So don't think that a base map is the only option. You can use any GIS data to help you get a good georeference. So don't think that you're stuck with just one data set there. Now, two cool sites that I'm going to put in the course that you can look at are going to be the David Rumsey Map Collection and the New York Public Library Map Collection, both really awesome sites. And what's neat about them that they've added in recent years is they added a way of taking their historic maps and actually georeferencing them. So you can actually be spitting these out as GIS data so that you can be using them. When we go to the archives in the Library of Congress, or we even go to their websites, you're going to find a lot of historical maps on there. And this is the process that you would use to get that as usable GIS data. So this really opens up a lot of opportunity for really neat data sets. And this is something that you're likely going to be doing in your project. Because we're doing a historical mapping project, you're likely going to need historical maps. This is the process you would use to get them to line up with all your other GIS data. So with that, I have one last thing that I want to mention. And I'm going to go to this data frame. Now, some of you know what's wrong with this, and I hope actually all of you know what's wrong with this, but this is the United States, and this is projected using a really not so good projection. And this is not the way that we need to see the United States. If we remember, the two appropriate projections for the United States are an Albers conic conformal, or Albers equal area, and a Lambert conic conformal. So what we want to do is set our data frame to one of those so that it makes our data look correct. So I'm going to go to the Coordinate System tab, and I'm going to change the display coordinate system. So I'm going to go to Projected, Continental, North America, and then select that conic conformal. And doesn't that look much better? The answer is yes. And then same for Pennsylvania. A lot of times you will see Pennsylvania added long and skinny like this. I don't want to see any long and skinny Pennsylvanias this semester in a cartography course. The appropriate display projection for this would be state plane. So I'm going to go to my favorites and change it. and notice how much better that looks. Now, one thing to be very aware of is that you are not changing the coordinate system of the data. You are just changing the way that it's displayed. So there's nothing changing in that PRJ file when you do this. This is just changing the display projection. So with that, good luck on this week's assignment. Hope you have fun with it, and pop me an email or a discussion board post if you have any questions. Okay, bye.